Right. Good morning, everyone. Welcome to our webinar, Balancing Scale and Savings, Expert Strategies for Kubernetes Autoscaling. Just to give you a heads up, we will be recording this session today. So if you're not able to attend the whole session or would like to share it with others, we will send out a recording after this is over. So we'll go ahead and get started here. I want to introduce our two speakers today. Matthew Lenhard is a co-founder and CTO at Positional, and he's also formerly of Contain IQ. And then we have Chris Reynolds, solutions engineer here at Kubecost. So today we'll be going over autoscaling strategies and tools, and then also a general overview of Kubecost. But we'll also leave some time at the end for you all to ask any questions that you might have. And I know that we did get quite a few questions submitted ahead of time. So we'll definitely start with those, and then we'll do our best to work through any that are submitted at the end of the webinar. But if we're not able to cover all your questions today, you're also welcome to reach out to us directly, and we can set up time to go over your questions in more details, or even set up time for a Kubecost demo. So with that, we'll go ahead and kick it off and pass it over to Matt.
Thank you so much, Dee. Yeah, so I'm Matt, currently the CTO and co-founder of Positional, but before Positional, I was the CTO at a Kubernetes monitoring company. So very familiar with Kubernetes. I manage and run all of our infrastructure currently, and I also did it at Contain IQ. So today I'm going to walk you through the, I guess, basic scaling strategies for Kubernetes. So I'm going to start with the vertical pod autoscaler, talk you through some implementation strategies, and then do the same for the horizontal pod autoscaler and the cluster autoscaler. Finally, I'll talk through some additional tools and wrap it up with how you can balance availability alongside cost savings with Kubecost. So yeah, the basics strategies are across these three core components: the vertical pod autoscaler, the horizontal pod autoscaler, and the cluster autoscaler. So the vertical pod autoscaler, pretty straightforward, basically watches pod CPU and memory. From there, it can generate recommended upper and lower bounds. And the gist of it is it's going to make your pods larger. So instead of scaling out the number of pods, it's scaling out how large a singular pod is based on the resources it recommends. So there's three main components in the vertical pod autoscaler. There's the recommender, and that monitors resource and metric history, basically to provide target values. There's the updater, that will evict pods when new limits are set. And there's the emissions controller. And that basically uses a webhook to set CPU and memory when pods are updated and evicted. So the core of the vertical pod autoscaler is on the mode setting. So off provides recommendations, but won't apply them automatically. Typically, this is what you see in production environments. The reason for this is because if you have it set to auto, it will evict and recreate pods. And that can be an issue because it takes a little bit of time for the new pod to spin up. And depending on how long it takes for like a new pod to be created, you can see service disruptions. So general best practice, like you see this in even the Kubernetes docs, is to use off when in production, but you're fine to use auto or any of the other values in staging or testing environments. So what does the YAML and the implementation look like? It's relatively straightforward. The kind is just vertical pod autoscaler. Target ref matches whatever workload you want to scale. So like in this case, I'm scaling an Nginx deployment. And then, like I said, the update mode is kind of what's core here. So make sure you have that set to off in production environments. From there, you want to set like typically the more important one here is probably the max allowed, because if the recommendation or the upper bound is too high, it can actually come in higher than the node actually has capacity for. And so that's something you need to be aware of, like making sure that your maximum values are lower than the overall capacity on given nodes in the cluster. Similarly with like the minimum, you want to make sure that you have some like sane default values here. So what are the limitations? Kind of like I just mentioned, the biggest one is you can't have it in most production environments applied automatically, because it can lead to pod evictions, because the pod must be recreated. It's unaware of the node sizes, can cause conflicts with the horizontal pod autoscaler. The vertical pod autoscaler can work in situations where maybe you're coming from like a monolith architecture where you can't necessarily scale out horizontally the number of pods because your application wasn't designed in a way to handle kind of like concurrent instances of it running. So it can be a way to essentially kind of account for applications or systems that weren't designed in kind of like a modern microservice type architecture. Yeah, so that leads me to the horizontal pod autoscaler. So this essentially works instead of scaling the size of a singular pod, it's going to scale out the number of pods. Implementation's pretty straightforward. Similar to the vertical pod autoscaler, you're going to want to set the target ref to match whatever workload you're scaling. You're going to want to set a minimum and maximum number of replicas. And then the important thing is the kind of like target metric. So in this case, I've got target CPU utilization. But I'll talk through a little bit more about how those metrics work in a little. There's also the imperative declaration. So essentially you're kind of just testing this out. You can do all this from the CLI. Something that I think is pretty interesting is you can also use the watch flag to essentially run load tests and see how the horizontal pod autoscaler kind of reacts to those load tests. It's a way to kind of help figure out those like values that you want to scale off of. So you can test out different CPU percentages to figure out where do you start seeing failures and what should you set it at. So by default, the horizontal pod autoscaler works with CPU and memory. That being said, it's pretty, I guess, relatively straightforward to set up custom metric-based autoscaling as well. So there's two, I guess, like different types of custom metric implementations. There's pod metrics. Those are averaged across all pods, and they only support a target type of average, obviously, because it's averaged across pods. And then you have a type of object, which basically just describes a different object in the same namespace and can support those value and average value for the target type. So finally, if you want to set up an external custom metric, you can expose like Kubernetes metrics API and create a custom metric. So in this case, I've done one for like pretty common use case, which is queue size. So say you have like a Redis, RabbitMQ application set up, you could essentially scale the number of pods based on how many messages you have in the queue. So any type of distributed job system would generally benefit a lot from this. Yeah, so what are the limitations? So you need to make sure your application's designed in a way to scale horizontally, which, kind of duh, but it's something you might not realize at first if you've got some type of in-memory queue or cache or something. You're going to need a way for the applications to ensure one-time delivery for messages, so that when you do scale out horizontally, you don't run into any issues. Like I said earlier, only CPU and memory are set up by default. So if you want to add custom metrics, there's some additional configuration there. It doesn't fix container level problems. So if you've got a memory leak in one of your applications, you're just going to keep scaling out horizontally, but it's not going to fix the root cause of the issue. And in some cases, it can even mask the issue. Finally, if the cluster reaches capacity in terms of nodes, this isn't going to add any nodes. So if you want to add another pod, the node's unschedulable, you're going to start seeing application degradation. Awesome. So that takes me to the cluster autoscaler. And this, differently than the pod autoscaler, obviously just adds nodes based on load. So it'll scale up and down the number of nodes based on the node utilization metrics. So this kind of differs based on the cloud providers. But what I really wanted to highlight here was Carpenter. Carpenter is a kind of like newer solution to scaling out the nodes in your system. Seems to be generally where things are headed. And it's, from my experience, able to do some really cool things. I think the setup's a little bit more straightforward than AWS, and it integrates with all of the existing cloud providers. So how does Carpenter work? The core concept here are provisioners. So provisioners are essentially like CRDs or custom resources that set conditions for like what nodes, how nodes should be created, what pods can be scheduled on them, how should they be cleaned up, kind of defines like your, I guess, auto-scaling strategy. And they do need to be mutually exclusive. So the second part of that is the deprovisioning. So provisioners can handle both like provisioning new nodes and deprovisioning them. So the way deprovisioning works is it uses a node finalizer, or essentially attaches a finalizer to the node to deprovision them when they're not needed anymore. And there's like 5 kind of ways it knows when to do this. So emptiness, no workloads are running. Expiration, you can set a TTL seconds until expired YAML value when you're creating it to essentially clean up old nodes over time. Consolidation, it basically will look at like, can this workload run elsewhere? If so, let's move the workloads around to clean up like excess or unneeded nodes. Drift is when nodes have drifted from their like spec over time. Finally, interruptions, so like a spot instance going, you losing access to a spot instance, or if there's health issues on the node. So there's kind of a few core things in the implementation of Carpenter I want to call out. In the spec, you want to set up the taints, which basically add taints to the nodes when they're provisioned. And this is to, I guess, control which pods will get scheduled on that node. So if the pods don't have the correct toleration for that taint, they won't be scheduled. Next is the startup taints. I call this out specifically because this can be like a gotcha. So these are taints given at creation, but that a daemon set will manually remove, or some other workload will manually remove after a given time. An example of this, like when you would need this, is if you're using a CNI like Cilium. This can essentially wait for Cilium to finish setting up the node before the pods will start being scheduled on that given node. And then limits set up like constraints for total cluster size. The implementation's pretty straightforward. There's basically, you set the key, an operator, and then a value, and it will tell the carpenter like what type of node you want. So in this instance, you know, less than 4 cores, less than 8 gigabytes, and we only want spot instances. So this kind of controls what nodes you're launching. Yeah, so that takes us through Carpenter. I wanted to call out specifically an article on Kubecost that I came through when doing a little bit of research, because it was super helpful, because the AWS configuration can be kind of annoying. You have to set up like all the necessary IAM policies, all the roles, and then you want to set up a service account role and role bindings and corresponding cluster role bindings for the autoscaler service accounts. And there's a great article on Kubecost that kind of describes how to do all of that. So what are the limitations? There is a delay for nodes to come online. So, you know, it may take a minute or two for AWS to, or whatever your cloud provider is, to spin up that instance and for it to become available for scheduling. So there can be brief periods of unavailability if you need to scale very quickly, or if you're seeing like application degradation in other areas. It's based on resource requests and not actual usage, so that's something you're just going to need to tune yourself. It's a little bit more convoluted setup process in my experience, because you're integrating with the cloud providers directly. The horizontal pod autoscaler and vertical pod autoscaler generally are kind of easier to get set up with. And it can lead to increased costs if your requests aren't properly tuned, because you're obviously going to be scaling up the number of nodes. If you're not careful, you're going to run into waste. So I wanted to call out a few supplemental tools that can be pretty helpful when you're thinking through all these things. So obviously Kubecost, to figure out how you you know, monitor spend as you're thinking about availability. It's, obviously, you know, you want to make sure your application handles spikes in traffic well, but at the same time, you don't want to be wasting excess resources to account for that. StormForge, which has like basically similar to like the HPA, can take a lot of the guesswork and automatically scale out your workloads and help you figure out what those limits should be. Carpenter, like I already called out, and Prometheus and Grafana. A lot of these metrics you want to be piping into Prometheus and Grafana to either alert on or help you kind of decide on a lot of these resource requests and limits. So how do you go about balancing the availability versus the cost? So there's a few core, I guess, like tenets here that Kubecost is pretty helpful with. And those are like allocation. So figuring out which workloads are driving costs. If you have a bunch of different node types and different workloads scheduled on them, it's really hard to figure out what workload is using up like the most resources. And Kubecost has like a great API endpoint to kind of figure that out for you. Right sizing, so that's figuring out how to set those requests and limits on the container, can be pretty confusing. And it's necessary for like all of these tools to kind of work properly. Finally, budgeting, so that you can ensure, like, as you're scaling over time, how does that impact your budget plan? How do you forecast these types of like auto scaling events? It can be really difficult. And with that, I will hand it off to Chris to walk through a quick demo of how Kubecost can do this from a UI perspective.
All righty. So let's first pray to the Zoom gods that screen sharing works, and then pray to the demo gods. All righty, cool. Everybody should be seeing my screen now. So Matthew had touched on 3 great points there. So we'll kind of dig into them on the UI side of things, as the API is just not as a cool looking demo as our UI is. So we're going to stick with that. So allocations. What he was talking about there is this is really kind of the chargeback, showback, shameback side of things. So when I, as a business owner or as a PaaS operator or even a developer, want to see how are we doing in terms of costs and efficiency, this is going to be the main driver of where we sit. So let's crank up. Well, we'll get last 30 days. We have the ability to aggregate by about 15 to 20 different Kubernetes concepts. But for simplicity's sakes, we will say just namespace. And what's cool about the multi-federated view here, we are actually viewing multiple clusters here at once. So I've broken it out. Let me clean it up a little bit to make it easier to understand. We'll just say Kubecost, click the plus button. So now you can see we've broken out Kubecost across what is 3 different clusters and 3 different cloud providers. But when we view it in a single aggregation, that is actually viewing CPU, GPU, RAM, our PV costs, networking, load balancer, our shared cost and efficiency. Let's really talk about efficiency here, because that's what really came up when Matthew was talking about these scalers. Is what is it's really going to be based upon your CPU and RAM requests. So efficiency is the max of your CPU and RAM requests over a given time period. So in this case, you can see we're at about 33% efficiency, which is actually pretty good from what we see with most of our customers. But we have the ability to say we'll sort here by efficiency. You can see that some of these are really low. So these are workloads, aka namespaces, that are requesting a lot of resources, but they're not actually using them. Versus on the flip side, these are ones that are using more than they've requested. And so we have that ability to scale and balloon outside of what we are normally doing today with that. So this is just giving us kind of 2 different views of, okay, we can either look at it from the cost over time or the efficiency over time and what we're doing within those workloads ourselves. So if we go back, say Kubecost, so we're pulling all of these metrics from Prometheus, and we have the ability to drill down and kind of inspect these costs and these efficiencies that we're seeing within these requests themselves. So we can see these efficiency scores that are generated either at the whole level here for the namespace or down at this point, the controller level themselves. And we can actually kind of keep going down the Kubernetes rabbit hole. And this will actually take us to our second point, right sizing, aka savings. So some of the things that we're looking at here, let's just clean this up a little bit so there's less to stare at. It makes it easier for everybody to understand. So in this, actually helps if you hit the plus button. I do this every time. There we go. Then hit save. So what we are looking at here is actually a savings page, and aka optimization and savings. So we are now seeing of what has been requested over a given date and time. So we'll say the last 48 hours, we can crank it up to the last 30 days if we want. We have these 3 different profiles that we normally talk about. And this is really where it really depends on the environment and your workloads and what you're wanting to achieve. So for production, we aim for about 65% resource utilization. For development, we sit around 80. For HA, obviously 50-50. And then for custom, you have the ability to target percentiles and the max for CPU and RAM and what those percentiles that you want to be. So having that play within the HBA request, what a lot of our customers do, especially with Carpenter, is say, okay, we're going to scale, we're going to deploy this workload. I need to know where we sit with things and what we want. So in this case, we're going to say cost analyzer. So now we can see the individual containers that make them up over the last given time range. And we can say, okay, here's the requests that have been made versus the what's actually been used and the costs that are associated with it. And in this case, we do have Grafana turned on. So these will take us to Grafana metrics, which we'll hear load in a hot minute. eventually will load here in a hot minute. We're not going to wait for it. But what this does is, okay, they make these API calls into the product itself, into Kubecost, from either the deployment pipeline, from their scalers, however they want to consume the data. Say, okay, based upon that profile, give me the recommendations for CPU and RAM so we can scale efficiently and on the cost side of things for those savings themselves. So in this case, generally for most customers, either the container requests or the clustered nodes themselves are going to be the greatest savings that they can achieve with it. And then the kind of third concept that Matthew took us to was budgeting, aka governance. So this is a relatively new feature for us that we've brought in. And when these customers and companies are starting their kind of their FinOps journey, budgeting is always going to be, you know, kind of the front and foremost in their mind. It's going to be what is going to be the largest cost for them, and what is the, how do we stay within the balance of being a good steward and a good tenant within our environment. So that's where budgets come in. So in this case, we'll just kind of walk through creating a new budget, give it a nice, lovely name. We'll say, give it a budget cap. You have the option to say, when does it reset on a monthly or weekly given time point and what day? And then in this case, either namespace or cluster. So we could just say Acme Fitness. And then how do you want to consume it? So you see these trigger percentages. You can say, okay, at 80%, send us an email, send us a generic Slack or Slack webhook, or send us out via Teams, and let us know this information and where we're sitting within those costs themselves. And this is kind of when, you know, you have those weekly meetings, you can see where you are with those spends and where you would be within those spends. On the flip side, what does it cost for, you know, the prediction of costs and the sharing of costs? When deploying your workloads, you want to know what is the cost to make these, you know, these cost determinations, and you can make these within the scaling, you know, architecture. So if you specify what is your workload here in the spec file, in this case, we're playing with this Pac-Man application, saying he needs 9 replicas. He's got, here's his labels. Here's the number of containers. Here's the CPU and the memory requirements that are needed. So obviously, Pac-Man is going to need a lot of information. So today, it runs as a kubectl command against the primary cluster. And the primary cluster in this case is hooked up to our cloud provider. So we are not using the default on-demand pricing. We do have the ability to pull back the billing reports and ingest true pricing that way. So when I'm going to go ahead and run this kubectl command and say, okay, give me the actual cost, it will know the cost per unit based upon CPU core and RAM core costs from Prometheus metrics married up to your bill from the cloud provider. We say, okay, hey, based upon this, here's what the estimated delta monthly change is going to be, and then the additional total monthly cost with that. So this really gives teams the ability to say, hey, okay, within that budgeting and governance side of things, either at the weekly, the monthly, between applications, between sprints, scrums, whatever you want to use it for, you can see the true cost of things and what it's going to cost to kind of adopt these practices within your environment. So with that, it looks like the demo gods have favored upon us, and I know we wanted to leave some time for Q&A. So Matthew, do you want to dive in with the first few that we have going on here?
I guess I'll get started with some of these that I can see in the chat here, and then we can jump into ones that were submitted afterwards or submitted previously afterwards. So I can see in the chat, Steve asked, thank you for the session. Can I use Kubecost for minor cloud vendors? I don't expect exact budget information because pricing models differ between vendors. However, I want to check the cost tendencies of Kubernetes objects. So I guess, how do you guys work with some of the smaller cloud vendors?
Yeah. So you'll see there in the slide, we have kind of that air gapped and on-premise. So if it's not one of those cloud vendors that is listed there, you do have the ability to do custom pricing as part of our enterprise product. And what you would do is you create an amortization table for your cost. So, including this applies to also on-prem CPU, RAM, GPU, all those individual costs down at the hour level. And then we can ingest that and apply those costs to those metrics that we're pulling in. So by default, you have to create the amortization in the cost table, which is usually the hardest part. We do have some blog posts that can help you with that and to give you, kind of a point into the right direction.
Awesome. There's another about granularity or I guess how do the different autoscalers react to granularity, and how do they
I
account
can
for
expand
things
on
like...
it.
Sure, go ahead.
Sorry to interrupt you. I was given the ability to talk. It's might be better explained this way. Basically, what I've noticed is that some of the services, they are requesting, let's say, 2.5 times more than they are consuming, but averaging by the hour, right? And once I look into the Grafana, into the actual CPU consumption, I see the spikes which are covering this 2.5 times. And the averaging might just choke. Basically, it doesn't show the true picture. And if we try to reduce the amount of resources requested, we basically going to choke the service or application itself. And my question is, how does the Kubecost account for that? Is there anything what can provide more like a true picture of like, hey, if you reduce it more than 100%, you're really going to run into troubles?
Yeah, so Chris, I can talk a little bit about the granularity, and then I'll pass it off to you to maybe how Kubecost might be able to help. But definitely agree, metric granularity can be very tough to, I guess, figure out. If you're scaling off of a custom metric, Grafana should allow you, or as you're exporting from Prometheus, you should be able to set up the Prometheus exporter to export the metric at like a given interval. And then depending on how you're, I guess, rolling those up. But that being said, I mean, if with extremely spiky workloads, there's always going to be, I guess, like some slack that you need to make sure is added. But yeah, I'll pass it up to you, Chris, to give any thoughts about how, I guess, like Kubecost can help with those types of things.
So the metrics that we pull from Prometheus, we do pull with the granularity of 1 minute. You can tune that up and down as need be. Minute is kind of that sweet spot of not hammering all the resources. For those more dynamic workloads, it kind of goes back to when I talked about those efficiency profiles. You always want to leave a buffer within anything. You never want to run everything at 100%. That's when you start kind of seeing things drop. And I think almost at that point, it's kind of a question about, architecturing the application at a larger scale and building those, almost like kind of building in tolerance for spot instances and that flakiness of if you run it too near line, obviously you're going to have resource loss and degradation. So most of our customers don't look for like minute granularity and costs. They look for it in like at max an hour. On the efficiency side, yeah, they look more of, is there a business drive around it, so like a Black Friday or a sales type event that where we know this is coming, and if they have that data, Kubecost data, Grafana, wherever the data scored is, and they use those laws of averages to kind of make a game plan.
Yeah, I'm talking about the workloads in the matter of like 1,000 pods and more in deployment and multiple deployments at a time in the cluster. So we being in a situation where we had one of the downstream services basically choking up for any different reasons, and it increases the load on the upstream services. And because we were not really super efficiently set, let's say like request was 100% higher than actual consumption, we were able to keep the system up and running. But if we would go for like a 70% efficiency, let's say, so usage around 70% of the allocated resources, then we might end up in the troubles. And some of the services, they are single threaded by the nature, and we run into the situations where having this extra headroom actually saved us. But again, relying on the tools to optimize the resource usage would have been kind of a little bit not precise, I should say, in that case. So I was wondering if it's actually possible. So you said the granularity is up to 1 minute, which is decent enough. I looked into the metric exactly as you said on the wider scale. So if I would do the averaging more than for like let's say 6 hours or 1 day, then it definitely just makes the spikes invisible, and then the tuning will be actually set wrong.
Yeah, no, you're correct. Yeah, and we've had customers who are more to tune it down. I think we've seen as low as 30 seconds to kind of account for those scenarios and those shorter-lived workloads, essentially.
Okay, but basically depends on how we pull the metrics from Prometheus. I got it.
Yeah.
Thank you.
Cool.
Awesome. Yeah, I think that kind of touches on the core of balancing availability versus cost savings, because having a little extra leg room can be helpful when you're seeing like dramatic spikes in load, but you know, you have to pay for those things.
Yeah.
Awesome. So see another question that just came in, less on Kubecost, but in your experience, what is the most aggressive method you've seen or you could recommend to get developers to set and maintain their requests correctly? I don't know if this is like a governance question, but there's a bunch of tools out there that will enforce these types of things on deployments.
I've got a good one.
Yeah,
Wall of shame. Wall of shame. That happens. They'll take API requests from our product, whether it be, you know, the budget, a namespace spend, request limits that are coming out of the product. They'll anonymize it and create a wall of shame. Everybody knows their individual, you know, code name for their application or whatnot. But you don't know everybody else's unless, you know, you start gossiping. But that has kind of, that's a culture change, right? And a lot of the data that comes from Kubecost, it's data. And we don't know the business behind it. We don't know the reasoning why requests are set that way, why things are done that way. We're just bringing you data. And at the end of the day, that data it's giving you the spark, the stick, whatever you want to use to have these conversations to make these cultural changes within, you know, your organization. And sometimes it is a wall of shame. It's, you know, gamified a little bit to, you know, make it fun to be more efficient with those resources. And then once you gamify it, okay, well, now you get an extra few gigs of memory free because you've had an X amount of percentage improvement and stuff like that.
Yeah, I like the idea of a wall of shame. Maybe a Slack channel that yells at people.
There you go.
But yeah, it's kind of there's definitely cage policies you can set in place that kind of enforce these things. But I do agree that I think it's a kind of a cultural thing at your organization that you want to try to foster. I was going to jump into some of the questions we got submitted beforehand, and then if we have time, we can jump back to these.
Yeah.
Some of the ones that are still coming in. How does Kubecost, I guess, handle multi-cluster? And what does maybe that look like? And
yeah, I kind of briefly touched on the demo, but you know, let me explain it a little more. So by default, we deploy as a workload in each cluster. We deploy via Helm chart, and we are running and sitting in each cluster at the end of the day. So when we're pulling our metrics, we pull the metrics from the underlying nodes, and then we marry those up with everything that's running on top of it. So we know for how long a pod was running with X, Y, and Z resources on a given node. And then we kind of aggregate and marry that all together to build you that holistic view of what is your Kubernetes cost spend. So in the, you know, when I was showing the UI, we were sticking with the namespace because it's the easiest concept. And with that filtering, I showed in the aggregation, we could break it out by individual clusters. So if you are multi-cloud, you can see, is it cheaper to, based upon discounts, whatever, to run in this cloud provider versus that other cloud provider. So because we run as a workload, it gives us that granularity to marry those metrics up to give you that kind of single pane of glass.
Awesome. There was another one about kind of like on-premise support. So that I can, I guess, start with like the auto-scaling side of things. The question specifically was, what are the solutions for scaling like an on-premise Kubernetes cluster? So that kind of depends on what your setup looks like. Obviously, like the horizontal pod and vertical pod autoscaler will work as intended, but if you want to spin up new VMs, that kind of is dependent on, I guess, like how you're provisioning virtual machines or servers in the first place. Like if you're using like a third-party provider for your on-prem solution, how the provisioning works for them. And then, Chris, if you want to touch on, I'm guessing it's pretty straightforward installing.
It is pretty straightforward. So a lot of customers we've kind of partnered with, it's either been like on the OpenStack side where, a new OpenStack node is brought online and then the underlying Kubernetes infrastructure is installed. So kind of technically we're almost to day 2 in that scenario of, okay, the underlying platform is up, the infrastructure as a service. And then now we're bringing up the PaaS side of things. Once Kubernetes is up, then we would just deploy as a secondary. So we have the concept, and this kind of also helps with the last question of the primary, which is your UI and API entry point. And then the secondaries, all they do is they write all their data to an S3 bucket. So as long as they can talk to that bucket, you install it into that Kubernetes cluster if it's not already there. If it's still part of the same cluster and you're just expanding out, we go ahead and we take care of it because it's just a new node coming online.
Got it. Yeah, that makes complete sense. There was another interesting one that I thought stood out a little bit, and it's, I guess, if you could address like one thing in terms of cost control in a Kubernetes cluster, like where do you even get started? Like what's the first thing you would do?
So the journey, understanding what your cost is always number one. So it's always that allocations page, but where do we find the savings? It's always in the containers, right? The container right sizing is always the largest cost because when folks are deploying applications, it's a Java application, so it needs 16 gigs of memory, even though it's using 900 megs. We all know those days. Or I'm just using the defaults that came from the Helm chart, and we're not, tuning properly. We're not observing. We have no observability side of things that it's bringing it in. That's where we see most of it. And then all of that trickles down, in the Kubernetes layer cake to like the underlying infrastructure, especially if it's on the managed side of things, with the underlying nodes and what they run on. And if they don't have RIs, if they don't have savings plans of, okay, how can we best build out the underlying Kubernetes structure, underlying infrastructure for it to achieve savings once we've kind of worked on the container side of things. So it generally starts at the container level.
Yeah, definitely seen that myself. It's hard sometimes to figure out how you set those resources, especially if you're not doing any type of like load testing beforehand, or if it's like a newer microservice that you're spinning up, and maybe it's in like a language or framework that's different. It can be hard to figure out what exactly you should be targeting there. Awesome. So I think we're close. I don't know if there's like maybe one final question we can tackle here that I thought was pretty interesting. It's if we could get examples of, I guess, savings we've seen or times when like auto scaling has had dramatic benefits. And I'll talk through maybe some of the auto scaling I've done and how it saved us. And then I'm sure you could talk a little bit through about some of the savings you've seen through implementing these changes. So out of my previous company, Contain IQ, we ingested a lot of metric data, log data. And yeah, I mean, the cluster autoscaler was integral in handling spiky loads, essentially being able to handle like our log ingest was almost entirely dependent on our customers and not us. So, we could see spikes from a few megabytes a second to, 10 gigs a second pretty dramatically over the course of like a few seconds. And so cluster autoscaler is pretty key in being able to make sure we were able to handle those kind of just like the spiky nature of the data we were dealing with. Yeah, then I'll hand it up to you, Chris, to talk a little bit about maybe some of like the cost savings that you've seen.
Yeah, I think typically we try to realistically understand that, we're not going to save you 100% of your Kubernetes savings, right? We will say anywhere from 20 to 60% because there's underlying business business reasons why you can't always achieve things at the end of the day. And that's why we provide data. We do provide actions on some things, but we can go into that to another time. I think one of our probably our best case, not to say case study, but one of our best advocates is Under Armour. Amy Ashby has done some talks for the FinOps Foundation. I want to say, and don't quote me on this, I think we're saving them close to about $1 million a month, and I might be completely wrong in that number, but we're saving them a large chunk of money per month on their Kubernetes spend. And she does a wonderful talk about how they go through their journey of getting there and achieving it to get to those those savings. And I think they were somewhere around 30% for them. So that number, that financial dollar, I may have been wrong, but it's closer, I think, to 30% savings on their Kubernetes bill. And it's always going to go back to that cultural change of getting there and then empowering folks with the data that tools in the toolkit provide to achieve those savings, and then to realistically implement them to bring those changes to save, ultimately at the end of the day, to be more efficient and to save money. So it's there's some good sessions out there, and I always plug the FinOps Foundation and what they do, and go to look, and that's always a good starting point, because that is the core of their charter and their mission, is to help bring these into realities within companies. Sounds pretty good to me. Those AWS bills add up quick. We've all been hit with a shocker before, and you didn't realize how many resources you're actually using. Awesome. I don't know, Chris, if you saw any other questions that you wanted to tackle here, but I think that was most of the ones that were submitted beforehand.
Thank you so much to both Matt and Chris today. I appreciate you all walking us through this, and I hope everyone has a good rest of your day.